So this is SIG Scalability meeting, 11th May 2023, and I can see that we have topics today. So maybe let's start with the KubeVirt.
Hi. I'm Ryan Halsey. I'll talk about KubeVirt. So there's a few people here today also who joined the call from this group. So just so you don't, if you don't know, the KubeVirt project, we actually have a SIG scale group in KubeVirt. We do some work testing scale and performance, and so we had a few people join today. I met with Wojtek at KubeCon, and I'm going to share a few things of what we've been doing. So if you don't mind, I'm going to share my screen.
Yeah, I think I need to give you permission. Give me a second.
Okay. I can also share it with you, the slides, but I can't.
Okay, I gave you like co-host.
Okay.
So now you should be able to host to present, I think.
Let me see. Okay, that should do it. Okay, you should see it now. Great. All right, so I put together just a little bit of content just so we can show you a few things of what we've been doing and have a discussion around a few ideas. Okay, so the KubeVirt SIG scale. I'm gonna move my panel here. Okay, there we go. All right, the KubeVirt SIG scale. So our mission at KubeVirt SIG scales, what we've been doing is KubeVirt maintains its own API server. It's got its own components, it's got a scheduler, got a bunch of things. We got our own workload that runs as a pod, but we have our own APIs like VMs, VMIs, and so forth. And so our perspective was that we should have our own scale and performance standards, tools, and best practices, and so on. And so that's really what we've been focused on in SIG scales. We're focused on these things, building out scale and performance standards and many of the tools around it. So I'm going to talk a little bit about how we do to measure. So you're going to see a common theme throughout this is we want to use all the common tools about how we measure, and that's Prometheus or having something on a local laptop. So what we do is we leverage, we have two metrics that we've created in Prometheus that we use heavily to do our measurements for performance at scale. First one is called phase transition times, and I'll go through that in more detail in another slide. The second one is the client Go HTTP calls to the Kubernetes API server. So the phase transition times we primarily use to measure performance, like P95. We'll look at like how long it takes for us to go through a few different phases, or our virtual machine to go through a few different phases to reach a running state. And then we have so the client Go, think of like how many HTTP calls are we making to the Kubernetes API server? This is like how many patches, how many times are we patching our virtual machine during its life cycle. And this is important, is obviously for scale, right? We want to be a good neighbor in the cluster. KubeVirt is just a guest. We don't want to be sending thousands of patch requests or unnecessary patch requests. So we monitor these things to make sure we're being a good citizen in the cluster. Okay, so those are the two metrics we use heavily. So a closer look at what these look like. So this phase transition times, what we did, so the process, or I guess the inspiration for this is we took that idea of a creation timestamp that you see on like pods or other objects, and deletion timestamp, things like that. And we extended it to also include other things that were important to us. So this is a picture of a virtual machine instance. And what this has is the specific phases that the virtual machine will go through before we're actually in a place that a person can use the guest. And so these phases, like pending, scheduling, scheduled, running, are all like have different steps. Like pending will be like, okay, we're waiting for the scheduler, the Kubernetes scheduler to find a place to land this workload. Scheduling, like we're in the process of being scheduled somewhere, and then scheduled means like we've found a node where this guest is going to land, and then eventually running is basically just means that the domain has been defined, like we've actually created it with Versh, Doesn't necessarily mean the guest is running yet, but it just means that we've actually defined the domain. And so basically the idea is we have this information, we have this granular look at what's happening. And so now we're exposing it. We've basically taken this and we've sort of done two things with it. We have we post the timestamps in the status on the object, and we do this when we actually go through the phase transition. So we don't like, for example, we don't like two update calls to do this. We take in the same update or the patch call, we will to change the phase, we actually will post this phase transition timestamp at the same time. And the second thing is we also get it in Prometheus. And so what this does for us is we end up with stuff like this. Like we build dashboards around this where we can clearly see like, okay, here's like what we go through for this VMI. Like here's with those granular phases, we can see all the different data about the phases and how long they take roughly. And so this gives us a really good picture of like how we're performing in our clusters. So we see like lots of patterns. We see sometimes different phases take longer, and it's really easy for us to tell, okay, exactly where we're getting stuck. And also for if we're running that in production, or if we wanted to do measurements, we can see like, okay, here's where our bottleneck is. Okay, so I'm gonna go to the HTTP calls. So like I mentioned earlier, this is like thinking patch calls like we're making to the Kubernetes API server. And so what we're doing is we want to measure this all the time. We want to run this. Basically what it is, we created a bunch of CI that will constantly measure this against different PRs, and we catch when we change this when there are changes. So for example, here too, actually in the last, I think, yeah, I mean this is just in the last 5 months, where we caught an increase in patch requests. And these were the 2 pull requests that we got them in. And it makes sense, like these have to do with like cleaning up finalizers and dealing with controller revisions. So they're important for actually doing management of virtual machines. But the important point is that we can see this. We can see this as as the code base evolves, we can see how this changes. And so obviously when we can see this, it means that hopefully we can eventually apply a number to this and get us a sense of like, okay, this is how we could affect scale. Like we're doing a lot more patches now with this. When we pull in this pull request, this could affect scale in some way. So I wanted to open up for questions or discussion, and this is just these are just some ideas of like things that we kind of look to want to develop when with you guys. And for kind of the question, I guess, that I get all the time is like how long does it take to get a virtual machine up and running if it has a bunch of things with it, like storage, and we use this kind of CNI and whatever. And the answer to the question is that it's unknown. And the reason is there's just too many variables for us to be able to know this. And so like I mentioned and showed earlier on the dashboards, like we can see with all our granular phases, like how long things take. But I have no idea, like, and even if I were to zoom in even closer to some of the steps, how long it takes for like a PVC to attach. Like I don't know what it is. And so that's kind of one of the things that we, at least initially, was looking to collaborate with you guys, and I'm sure there are other ways as well, but like find ways like that we could look to measure some more, and look for ways that we can try and zoom in on some of the different characteristics that or I guess the different phases that different workloads go through with pods, or even things in the scheduler of PVCs. So these are just some examples, like PVC attachment, maybe network attachment, or any other pod conditions that we can think of beyond just a creation timestamp, or some things that we had in mind, the things that could provide a more granular picture of like what an end-to-end flow would look like. And so anyway, I wanted to open up for questions or thoughts on this. I'm definitely open to hearing what you guys have to say. And that's my last slide. So any questions or thoughts that people have?
Yeah, so I think thanks. That was great, and that was like Super useful. I think in general, like the defining like what or figuring out like what takes a significant part of time is not a problem that we really solved well anywhere in Kubernetes. I think that the idea or the path that we are trying to go with through the project is like integrating better with tracing, but we still didn't figure out how to do it well. So we are focusing on like smaller parts of the system now. Like I pasted to the chat like one of the two caps that we are trying to pursue, which is like integrating kubelet with tracing. Um,
Mhm.
I think there's also another one that I can find, which is like integrating API server with tracing. This doesn't like address the neither of those addresses like the like um the really cross-cutting operations that take number of controllers and so on and so on. But hopefully, based on the learnings that we have from from those, we will be able to somehow better instrument the system. Um, but I guess like the main point that I wanted to say is that we didn't really figure it out well in the project anywhere yet.
Gotcha. Yeah, I from my perspective, I don't know. Does this maybe you can tell me if this sounds crazy, but my understanding was that and this is just a like I don't know. I'm just guessing here. Like we have PVC is a bunch of phases, right? Like there's like I don't know. You can I think there's an attached phase, there's a pending phase, or something like that. Well, I was wondering, like, if let's say we were to pursue something like this, kind of similar to what I was talking about with like what we do now with virtual machines, would it make sense, like, if we were to, the moment when a PVC changes its phase to something else attached or whatever, we emit a metric. Maybe it doesn't have to be on the object. Maybe we could attach it to the object, like the creation timestamp. Maybe it doesn't make sense. I don't know, but even a metric would do. I mean, I think that would help a lot. And does that make sense, like as an idea? Like, do you think that would sort of get us closer to what our goal is? Like answering that question of like how we can get through like the more granular phases of what goes into getting a pod up and running.
I I think I think what I found a bit unique about what you're doing here is you're trying to kind of embed the trace into the status of objects. So the metrics aspect that you're talking about, I believe we have it at few places already today. For example, with the API server for different parts of the API path, and Kubelet also, for example, has some metrics around volume mount latencies and stuff like that. The thing with them is they aggregate, so it's you kind of know more about the trends and like how in general things are doing. It depends on what you really want. It felt like when you showed the CRD for the virtual machine, you want to have the record per object. So I guess if you need that level of granularity, you will need to persist this kind of data somewhere. Now, whether you do it on the object itself, or I was actually just looking at the cap that Wojtek shared, and there it seems like, if I'm reading correctly, they are trying to use some sort of a different object type or data structure for actually holding the traces that are disjoint from the object.
It's not even an object. It's like integration with open tracing in general. So
Okay. Open telemetry collector.
open telemetry. The names of that were changing over time. So I'm not sure which is the current one. Yeah.
Okay.
Yeah, but in general, like I agree with like what Shyam just said, that like it depends on the goal that you want to achieve. If you want this for debugging why my single instance took longer or whatever, like what was happening, then metrics aren't super useful for that. If you want to use it as a general information for what are the slowest part and what we potentially should focus on to optimize, then metrics sounds like a reasonable option.
Yeah, it's it's the latter. It's like, right, finding, like if I were to, it's like answering that question. Like you asked me, how long does it take for this virtual machine to go from, you know, the moment I created it to the moment I can hand it off to someone to use. It's getting it down to getting the granularity enough that I could say, okay, we clearly have a bottleneck with whatever we're doing in storage. You know, I can see it in, and I can see it in our metrics that it's taking longer than right now than it should be. You know, whatever that is, and I can clearly see that, or whatever other phase that we could point to as being problematic.
One more thing I wanted to add, like the metrics or things you're looking for are mainly coming from kubelet side, and they're not from the API server side, like network attachment and the volume attachment. So one possibility could be like something which API server does is audit logs, and start in the recent Kubernetes versions in audit logs, we have started adding annotations for each step. So where the latency is coming from, you could see in those annotations. So we could do something similar in kubelet. Maybe it's audit log or something else with the annotations where when a pod is getting created in kubelet, a network gets mount, volume gets mount, it's an annotation, and network gets created, that's an annotation. So when you are checking for a particular pod in kubelet, like why it was delayed, you could just see those logs in kubelet and tell. That could be another way.
The tricky part with going with logs is so now that could work. No, but the problem is that, like, how do we view it? How do we take this and analyze and view it? And then we would need to have, I mean, what would maybe like Kibana or something, which is fine. Like you could do it that way. I guess you could use Kibana to get you that information.
Sorry, I didn't get the last part. What's the tricky part with the
So
logs?
yeah, what I'm saying is, like, so you would need something to, so like it's aggregating the data. How do I take the data and analyze it? I guess that would be the problem. How do I, like, I'm not just going through the logs and picking out individual pieces and looking at the latency right. I'd want to have a tool to deal with how to analyze it. So like, you know, maybe Kibana or something is what I was saying. Maybe you could use to accomplish this. I don't know if that's the purpose of the audit tool. I've never used it, but it sounds like maybe you use Kibana to analyze it.
Right, yeah, makes sense. No, this is more getting granular data on a particular pod, for example. But if you are, as Sham was mentioning, if you're looking for trends, then the metrics would support that.
Okay.
Also, like the other thing is, if you're capturing every single phase transition on the object, and does it mean that over time your object is going to grow, or you're gonna,
They
or is
can,
just bounded?
there's a fixed, it's bounded. There's a fixed number of them. We're only gonna post so only these 4. And then what we do is like we use the creation timestamp, and we also have a deletion timestamp, and that's, so our starting phase, creation timestamp, deletion timestamps, the end phase, and then these 4 in the middle.
All right. Okay. Yeah. So today in our scale tests, this is a bit interesting in the sense that in our scale test today, we also have to measure this, the one that we run using cluster loader. We're kind of getting these bits of informations from things like events and like modifications to the pod itself, like creation timestamp, schedule events, and stuff like that. You're yeah, you're
Well, that's
making
interesting.
it.
So how do you get the scheduling? Like, when you said like scheduling, what is that? That's like, so when the pod is what?
It's Maybe Wojtek or Marcel, you remember? Is it the event, the bind event, or is it something on the pod? I don't know if the pod itself marks. But it's essentially, I think, one of those two, where we either check, I think, for the event that scheduler emits when it schedules the pod, or something on the pod itself. I can't recollect which field.
Yeah, I think if I remember correctly, like for scheduling, we are relying on events, and which isn't great, by the way, but it's where we are. And for phases within what kubelet is doing, I think we are relying on fields from the pod, but we also like extended the metrics on the kubelet, and we would like to, or maybe we already did. I'm not following that closely, to be honest, but we are trying to migrate a bunch of that to rely on the metrics for aggregations and for like the aggregated view of the like how system is behaving, and like on those individual fields in the pods or events only for debugging individual stuff purposes.
Let's see.
I had a follow-up question on that. So I think the way how we collect the metrics, as in, is it coming from the phase transition timestamp or is it coming from the kubelet, that really does not matter. All we need is a breakdown of, let's say, if the creation to running time went really high after a particular release, was it related to a kubelet or was it related to something in the KubeVirt stack? So keeping that in mind, is there a reason why the scheduling times are collected from the events and not from the scheduler emitting those latencies in form of metrics?
I think it's relying on the metrics is something, or migrating more to a metrics in certain places is something that we started more recently. I think ideally we would like to rely on metrics as much as possible. It depends exactly what exactly do you want, because it's a matter of granularity also. Like it's in particular it may be hard to so for scheduler you can emit a metric. Maybe that doesn't make sense what I'm saying. No, I wanted to say that like you can emit a metric when you are making a scheduling decision, but it's probably what you want from scheduler and what when event is happening. I guess I wanted to say that like we are potentially ignoring the part of like sending the request to the API server and so on, but it's probably workaroundable anyway, and it's probably not what we are interested in anyway. So
if scheduler emitted a metric, which is the difference of the pod's creation timestamp and the point where it succeeded to schedule, I guess we could collect the P50, P90 values.
Yep.
It'd actually be more accurate than what we are doing today, which is, I believe, it's second level granularity. It's not even milliseconds or anything. So yeah, Alay, I think really, I guess we could move to that model as well. Like Wojtek is saying, it's just we probably have
I
it, or
think
maybe
that's the approach we have been following. And regarding granularity, I think we are also trending data. So the implementation is such that it comes on a per object basis, but at the high level, we are looking at P95 of creation to running. or an average, right? So I think moving to that scheduler metric will then help us align that, okay, KubeVirt started running on 127 Kubernetes, and it is seeing more time being spent in scheduling phase. Let's go look at Kubernetes 127 P95 for scheduling and see if there is a problem there or something like that. So it helps correlate the trends in both the projects.
Yeah. Yes, that makes sense. It's also what a lot of what we are doing today with the tests we are running, correlating a bunch of metrics with time.
Also, you mentioned that you are wondering whether the change comes from KubeVirt or Kubernetes itself. So I was wondering, maybe it would make sense in your case to actually like run KubeVirt with fixed version of Kubernetes, for example, right? And then you are sure that all the changes come from KubeVirt. This is also something that we use for testing various things, where, for example, with the Golang compiler, where we have like fixed Kubernetes version and we just test Golang compiler. And this can also like just reduce the noise that comes from both projects at the same time and help you debug further.
Yeah, yeah, we do that. We test across, I think, I think it's 3 releases. So yeah, I mean that is a point. Yeah, we'd want to see that stuff. But I mean, it goes further, even like, you know, like I was saying, like we want to see deeper into, you know, exactly like, you know, we can see that, okay, maybe it's slower, you know, maybe it's because of the KubeVirt change, maybe it's Kubernetes change, but you know, where we're curious to see like even deeper, like what is it that it's going wrong in the scheduling, like, you know, maybe we'll file a bug. Like that's kind of where we want to go with it. It's like, you know, we can see that, like, you know, we've got a lot of large clusters. We run the stuff. We want to see exactly where it is. We want to, you know, we want to drill a little deeper and hopefully find some things.
Yeah, so personally, I think for right now we are using metrics and logs mostly, unfortunately, and it's painful.
Yeah, so I guess like what this has been a really good discussion, by the way, and I guess like what I as a goal, like for us, I mean, this is something that we've been doing and driving within KubeVirt, and it makes sense to us, and it's worked well for us. And I mean, we'd be interested in helping to contribute to this. This has been something that we care a lot about, because it's like KubeVirt is like, I guess the point we're making here pretty over and over again is like that KubeVirt's just a guest and the cluster, and right, like we use pods, you know, like we use PVCs and stuff, and it's got all these components, but you know, we also want to make Kubernetes, and we want to make it, you know, improve its scalability and performance, because we rely on it heavily. So it's definitely a shared goal on this, and so we'd love to help, you know, in this area, if that makes sense as a direction. If you guys think, sounds like it does, then
yeah,
you know, we'd love to help contribute that.
So one thing I feel maybe you can help, given your familiarity with the space, on the things that are happening on the node side, right? Today in the test for us, let's say when we are creating pods, the granularity at which we operate is after the pod is scheduled and the and kubelet starts running. We, for example, don't know how much of that time is going into parts like, for example, mounting a secret or mounting a config map into the pod, or like things like fetching an IP for the pod IP assignment. So if there is a way you can actually take your knowledge here and kind of measure that, maybe via metrics or maybe something else, it'd be interesting to see that added as a measurement, which is a concept in our load testing tooling, to kind of measure some aspect of how the system is behaving. So you could add a measurement for that. You can play around with it. We're happy to help you there. Marcel Wojtek, I've been using that for a long time for these skill tests too.
Sure. Yeah, we can do that. What would you suggest is, so what we could do is we can write some things up and as what we think would be an approach. What would you suggest is the right way to approach this? Is this something we should, like, we can come back to this meeting and share our thoughts on this if you guys want, or we can write an issue or something, or what would you suggest?
Yeah. I think anything that's convenient for you, an issue, or you can come back to this meeting. But also, I guess I'd say start by playing around with that tool and see if there's ways in which we can enrich some of that information with these tests. And
Okay.
of course, you can also kind of post any questions you have on the SIG Scale Slack channel and maybe tag one of us.
Okay. Yeah, we can do that. And the tool is the cluster loader. Is that the tool?
Right. Yeah, that's the
Okay.
one.
All right.
So it doesn't have node level measurements today, and that's something you can add there.
I'm wondering about one more thing, because we mentioned that there are multiple phases for example, pod scheduling. And I'm wondering, maybe we should even have like some brief summary of metrics that we already have and we can use for debugging, because I'm not sure if I'm personally aware of all of them, like with PVCs, for example, or other stuff. And maybe we could just even like start with metrics to understand like what we have covered and what we don't already.
Yeah, we can take that as part of our approach. We need. I don't know the answer to that either. So yeah, and I think we want to know that. I think it's important. So we can do that as well. We can come up with some of what's the current set of things that are available, and we can talk about them.
Yep. Cool. Thank you, Ryan, Ale, and everyone else who joined. I guess we're over time, so we should wrap it up.
Sure. Thank you very much, guys.
Thank you.
Thank you. It's just really interesting to see this. So thanks for bringing this up.
Of course. Yeah. We'll
Yep,
see you guys
thanks a lot.
online and in future meetings. Thank you very much.
Thank you. Bye.
Thank you.
Yeah, thanks for the presentation.
Of course.